This is Spacetime Series 22, Episode 50. Coming up on Spacetime, a new idea to explain the existence of ancient supermassive black holes, NASA opens the International Space Station up to tourism, and the mystery of the galaxy with no dark matter finally solved. All that and more coming up on Spacetime.
Welcome to Spacetime with Stuart Gary.
A new hypothesis has been developed claiming supermassive black holes can be created without first needing a star or stellar remnant to collapse. The findings, reported in the astrophysical journal Letters, provides a new explanation for the presence of supermassive black holes in the very early universe, long before they could have reached their gargantuan sizes through the merger of stellar mass black holes. Black holes are the most intense gravity wells in the universe, regions of infinite density in zero volume, where the gravitational pull is so strong nothing, not even light, can escape. Stellar mass black holes are formed by the death of some of the most massive stars in the universe through supernova explosions or through events such as neutron star mergers. But supermassive black holes are far more mysterious and difficult to explain. We know they're millions to billions of times larger than stellar mass black holes, and we know they're found at the centers of most, if not all, galaxies. During the past few decades, astronomers have discovered many supermassive black holes at really high redshifts, often a billion times more massive than the Sun. And that means they must have already been in place and really big when the universe was still really young, say 13 billion years ago. And the very presence of these young yet very massive black holes questions science's understanding of exactly how black holes form and grow. It means they can't all grow simply through the merger of stellar mass black holes. And that's where this new model by Western University's Shantanu Bissau and Arpan Das comes in. It's based on the assumption that supermassive black holes can form very quickly over very short periods of time and then suddenly simply stop growing. Bissau says there is indirect observational evidence that black holes can originate from direct collapses and not from stellar remnants. So a galaxy's worth of gas can simply collapse down to form a black hole directly without first needing to form stars and planets and stuff. Bissau and Das developed their new mathematical model to explain this by first calculating the mass function of supermassive black holes that form over a limited time period and undergo a rapid exponential growth in mass. They say the mass growth can be regulated by the Eddington limit that is set by the balance of radiation and gravitational forces and can even exceed that limit by a modest factor. Their direct collapse scenario suggests that supermassive black holes only had a really short period of time where they're able to grow really fast. And then at some point, because of all the radiation in the universe created by stars and other black holes, their production came to a halt. The authors claim their direct collapse scenario allows for initial masses that are much greater than those implied by standard stellar remnant scenarios, and all this goes a long way to explaining observations. Bissau believes that these new results can be used with future observations to help infer the formation history of extremely massive black holes which existed in the very early universe. I'm Stuart Gary. You're listening to Spacetime. Well, it looks like NASA's about to follow in the footsteps of the Russians and start carrying space tourists up to the International Space Station. But it won't come cheap. Return tickets are likely to cost around $60 million per flight, plus a further $35,000 per night once you're aboard the orbiting outpost. NASA's Deputy Director of Space Station Operations, Robin Gatens, says up to 2 short private slots will be made available each year for private astronauts flying missions up to the space station lasting up to 30 days each. The move is being seen as part of plans by the White House to privatize the space station in 2025. That'll help free up money for NASA to focus on its new Lunar Gateway space station, as well as a base on the Moon's surface near the South Pole. You may recall between 2001 and 2009, the Russian company Space Adventures organized for 7 space tourists to take trips to the space station, utilizing spare seats available on Soyuz flights. Russia charged around $28 million for each round trip. But that operation was stopped when NASA mothballed its space shuttle fleet in 2011, forcing all space station crew to fly up on Soyuz capsules, meaning no spare seats would be available for tourists. Now, with the expected commencement of commercial crew operations to the orbiting outpost by Boeing and SpaceX expected to start later this year or early next, NASA appears to be looking for new commercial opportunities for tourism or business ventures. To find out more, Andrew Dunkley is speaking with astronomer Dr. Fred Watson.
We've talked about space tourism and the organisations, private organisations that are looking at putting people into space, suborbital flight, that kind of thing. People get to experience for $200,000 a pop or whatever it is, 0G for a short period of time and then glide back to Earth or get rocketed back to Earth or whatever. It depends on who they go with, I suppose. But now NASA's playing the game.
Yeah, they are. That's right. And I guess you can put it in context. The context is that the current US government administration sees the private sector essentially taking over the space station within the next decade or so. It may even be before that, it might be within the next 5 years, that NASA wants to open the station to private industry and that they will eventually, private industry will take over the running of the space station for whatever purposes might be deemed necessary. And one of those purposes could well be tourism. So this is a sort of opening gambit in the private sector for NASA to start opening up the possibility of space tourists now to ease the transition from the publicly owned sector to the commercial sector. So we've got the deal that you can now buy holiday on the International Space Station, as you've been able to do before. For about a decade, during the early 2000s, a company called Space Adventures brokered a deal between Roscosmos, the Russian space agency, and a few really wealthy people who wanted to go into space. Because in those days, while the shuttle was still flying, US astronauts were ferried up and down to the space station with the shuttle. But cosmonauts went with a Soyuz spacecraft, which was a 3-seater spacecraft, but only 2 were used. So Space Adventures did this deal where a passenger could fill the third seat.
That's right.
I think there were 7 takers for this. The least that was paid, we know, was $20 million for a few days on the space station. And it was probably more than double that for the most expensive one. The prices that are being quoted now, though, are a bit higher than that because the ticket to get there could be as much as $58 million US. And this would come from one of the organizations that are going to be ferrying stuff up, most notably SpaceX, which is interesting. I would have thought the price would have come down because SpaceX, of course, reuse their boosters, and that means that their price per kilogram to get into orbit should be cheaper. Anyway, that's the price that's being paid, and there is a daily rate for the space station of $35,000 per night. That probably includes a cup of tea in the morning as well. Kind of hope so.
That's Professor Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. Astronomers think they've finally developed an explanation for a mysterious galaxy that appears to have no dark matter. It turns out the explanation's fairly simple. The galaxy may simply be a lot closer than originally thought. The discovery of the ultra-diffuse galaxy Ngc 1052 DF2 in the constellation Cetus raised eyebrows because observations suggested it had very little, if any, dark matter. Galaxies with no dark matter are impossible to understand in the framework of current theories for galaxy formation. That's because the role of dark matter is fundamental in causing the collapse of gas to form stars. Dark matter is one of the biggest mysteries of science today. Scientists have no idea what dark matter is, even though it makes up some 85% of all the matter in the universe. It seems to be invisible and seems to act only gravitationally with normal matter, the stuff stars, planets, asteroids, houses, cars, trees, dogs, cats, and people are made of. Astronomers only know dark matter exists because they can see its gravitational effect on normal matter, such as preventing galaxies from flinging apart as they rotate. Primordial black holes and hypothetical subatomic particles such as axions or sterile neutrinos are among the most popular current ideas to try and explain dark matter. Scientists have used underground observatories, detailed studies of objects in the halos of galaxies, and experiments at the world's largest particle accelerators to try and uncover dark matter's secrets. The original observations of Ngc 1052 DF2, reported in the journal Nature, suggested it was some 64 million light-years away. But a new study by scientists with the Institute of Astrophysics in the Canary Islands suggests the galaxy is a lot closer than that, just 42 million light-years away. A report in the Journal of the Monthly Notices the Royal Astronomical Society claims the new results mean the parameters of the galaxy inferred by its distance have now become normalized, and they now fit in with observed trends traced by galaxies with similar characteristics. The authors used 5 independent methods to estimate the distance of this galaxy, finding that all of them coincided with just one conclusion, namely that the galaxy is much nearer than the value presented in the earlier research. The most relevant datum that has been found through the new distance analysis is that the total mass of the galaxy is actually only around half the mass estimated previously, but the mass of its stars is only about a quarter the previously estimated mass. Now, what all this implies is that a significant part of the total mass of this galaxy must be made up of dark matter after all. The results show the fundamental importance of an accurate measurement of galactic distances, something that's not always easy to do. You're listening to Spacetime. I'm Stuart Gary. And time now to turn our eyes to the skies and check out the celestial sphere for July on Skywatch. July is, of course, the 7th month of the year in both the Julian and Gregorian calendars. It's named after the Roman Emperor Julius Caesar, who was born during the month. Prior to that, July was simply called Quintilis, which is Latin for 5th. On average, July is the coldest month of the year in the southern hemisphere, which is experiencing winter right now. It also marks the time when planet Earth is at aphelion, its furthest orbital position from the Sun. Of course, temperatures, or more accurately seasons on Earth, aren't dictated by distance from the Sun, but rather by the length of the day and hence the amount of sunlight a given part of the Earth receives. All that is governed by the tilt of the Earth's axis. Consequently, that's why July is on average the warmest month in the northern hemisphere, which is experiencing summer. During aphelion, Earth is on average about 152.1 million kilometres from the Sun. That's about 5 million kilometres further away than during perihelion, when it's at its nearest orbital position to the Sun, and about 147.1 million kilometres away. This year, aphelion occurred at 8:10 in the morning on July the 5th, Australian Eastern Standard Time. That's 6:10 in the evening of July the 4th, American Independence Day, US Eastern Daylight Time, and 10:10 at night, July the 4th, Greenwich Mean Time. Over cosmic time, these dates will change due to variations in Earth's orbit known as eccentricity. Eccentricity involves changes in how elliptical Earth's orbit is around the Sun. See, none of the planets orbit the Sun in perfect circular orbits, although Venus and Neptune are the closest. All have elongated orbits that vary slightly over time. Okay, looking up at the skies, and as Jonathan Nally will tell us in a few moments' time, the Southern Cross is at the highest point of the southern sky this time of year, pointing directly towards the southern celestial pole. The Southern Cross is within the constellation Centaurus, the centaur, the half-human, half-horse of Greek mythology. The creature is holding a bow with an arrow. The centaur's front leg is marked by the 2 pointer stars Alpha and Beta Centaurus. At 4.3 light-years distant, Alpha Centauri, the second of the 2 pointer stars from the Southern Cross, is also the nearest star system to the Sun. Centaurus's back arches over the Southern Cross, and just above this is Omega Centauri, a spectacular globular cluster, visible with the unaided eye from dark locations. Globular clusters are tight-packed spheres containing thousands to millions of stars, which were all originally born at the same time out of the same molecular gas and dust cloud. The Omega Centauri globular cluster is about 16,000 light-years away. It's one of the largest and brightest of the roughly 150 globular clusters known to orbit around the Milky Way. Centaurus was included among the 48 constellations listed by the 2nd century astronomer Ptolemy, and it remains as one of the 88 modern-day constellations. Turning to the right or west, and you find the constellation Leo the Lion just above the western horizon. Its brightest star is Regulus, or the Little King, located about 79 light-years away. Regulus, designated Alpha Leonis, is actually a 5-star system organized into 2 pairs. Regulus A itself is a spectroscopic binary comprising a spectral type B blue-white main sequence star, about 4 times the mass and some 288 times the luminosity of the Sun, and a faint companion star which is thought to be a white dwarf, the stellar corpse of what was once a Sun-like star. Spectroscopic binaries are stars that can't be resolved by optical telescopes into 2 separate objects and can only be separated by observing their individual spectroscopic Doppler shifts as they orbit around each other. Located further away are Regulus B, C, and D, which are all dim main sequence stars. At the opposite end of the constellation from Regulus is the star Beta Leonis, or Denebola, the horse's tail. It's also a luminous blue-white star, thought to be a spectral type A, about half as bright as Regulus, and the 3rd brightest star in the constellation Leo. Beta Leonis has about 1.8 times the mass of the Sun and is about 15 times as luminous. It's suspected of being a dwarf Cepheid or Delta Scuti type variable star, meaning its luminosity varies very slightly over a period of several hours due to pulsations on its surface. Leo also contains many galaxies, including the spiral galaxy Messier 66, as well as Messier 65 and NGC 3628, which together are known as the Leo triplet. Located some 37 million light-years away, the Leo triplet has a somewhat distorted shape. That's due to gravitational interactions between Messier 66 and the other two galaxies, which are cannibalizing stars from it. It's thought eventually the outermost stars may form a dwarf galaxy orbiting M66. Both M65 and M66 are visible with a large set of binoculars or a small backyard telescope, but their concentrated nuclei and elongation are really only visible using a larger backyard telescope. Other bright, well-known galaxies in Leo include Messier 95, Messier 96, Messier 105, and NGC 3628. M95 and M96 are both spiral galaxies, each about 20 million light-years from Earth. Both look like fuzzy objects in a small telescope, but show off their spectacular structures in larger instruments. M95 is a barred spiral. Another barred spiral, NGC 2903, is thought to be similar in size and structure to our own Milky Way galaxy. It was discovered by William Herschel in 1784. Close to the M95-M96 pair is the elliptical galaxy M105, which is also thought to be about 20 million light-years from Earth. The constellation also contains what's known as the Leo Ring. Actually, it's a cloud of hydrogen and helium gas orbiting two of the galaxies in the constellation. Above Leo is the constellation Virgo, the Greek and Roman goddess of wheat and agriculture. Virgo's brightest star, Spica, is visible high above the western horizon and is located about 250 light-years away. Spica is Latin for the ear of wheat, which Virgo is holding in her hand. Spica, or Alpha Virginis, is the 16th brightest star in the night sky, and it's both a spectroscopic binary and a rotating ellipsoidal variable. That is a close binary system whose stars are not eclipsing, but are causing apparent fluctuations in their brightness simply because of changes in the amount of light-emitting area visible to the observer. Spica's two main stars orbit each other every 4 Earth days, and are so close they're egg-shaped rather than spherical, and can only be separated by their spectra. The primary is a blue giant variable beta Cepheid star, which undergoes small rapid variations in brightness because of pulsations on the star's surface. The pulsations are thought to be caused by the unusual properties of iron at temperatures of 200,000 degrees Celsius in the star's interior. It has about 10 times the Sun's mass and about 7 times its diameter. The secondary star is somewhat smaller than the primary, but still about 7 times the mass of the Sun and at least 3.6 times the Sun's diameter. Okay, turning to the north now, and to the constellation Bootes the herdsman. You'll see a bright orange-red star, Arcturus, Alpha Bootes, just above the northern horizon. It's a red giant, located some 37 light-years away, a bloated, aging old star, some 7.1 billion years old, and now reaching the end of its life. Although not much more massive than the Sun, it's expanded out to some 25 times the Sun's diameter, and will soon puff off its outer gaseous envelope as a planetary nebula, in the process revealing its white-hot stellar core, a white dwarf which will slowly cool over the eons of time. Another bright reddish-looking star you'll see this time of the year, this time in the east, is the Red Supergiant Antares, meaning the rival of Mars because its appearance and location in the sky appears to be to the opposite of where Mars is in the sky. Antares is one of the biggest known stars in the universe. It's enormous, some 883 times the Sun's radius, 18 times its mass, and 10 times its luminosity. Despite being some 550 light-years away, Antares is still the 15th brightest star in the night sky. Unlike the Sun or Arcturus, the death of Antares will be a far more spectacular event. Antares is destined to explode as a core collapse or Type II supernova. When it does so, sometime in the next few 100,000 years, it'll appear as bright in the Earth's sky as the full moon, and will be quite visible during daylight hours. Antares also has a companion star, Antares B, a spectral type B blue-white main sequence star, more than 7 times the Sun's mass and 5 times its diameter. Antares marks the heart of the Scorpion in the constellation Scorpius. Below Scorpius is the constellation Sagittarius the Archer, which points to the centre of the Milky Way galaxy. Sagittarius is commonly represented as the winged centaur pulling back a bow, which is aimed at Antares. The centre of the Milky Way and its supermassive black hole Sagittarius A star lie in the westernmost part of Sagittarius. Sagittarius A star is roughly 27,000 light-years away and has some 4.3 million times the mass of the Sun. The brightest star in Sagittarius is Epsilon Sagittarii, or Caus Australis, the southern part of the bow. Epsilon Sagittarii is a binary system located some 143 light-years from Earth. The primary star is an evolved spectral type E blue giant at the end of its life on the main sequence. By the way, the main sequence is when a star is fusing hydrogen into helium in its core. It has about 3.5 times the Sun's mass, almost 7 times its radius, and is radiating around 363 times the Sun's luminosity. It's also a really strong X-ray source, and it's spinning very rapidly, with an estimated radial velocity of some 236 kilometers per second. Now, this system also displays an excess of infrared radiation emissions, and that suggests the presence of a circumstellar disk of dust. The second star in the system appears to be inside this debris disk. Astronomers think it's a spectral type G yellow dwarf star with about 95% the mass of the Sun. Sigma Sagittarii, or Nunki, is the constellation's second brightest star. The name Nunki is Babylonian, but its meaning is unknown. It's thought to represent the ancient Babylonian sacred city of Eridu on the Euphrates River. Now, if correct, that would make Nunki the oldest star name in use. It's a spectral type B blue star, located about 260 light-years from Earth. It has about 8 times the Sun's mass, about 4.5 times the Sun's radius, and about 3,300 times the luminosity of the Sun. The Sagittarius constellation also hosts many star clusters and nebulae, including some of the best-known astronomical objects in the sky. These include the Lagoon Nebula Messier 8, a spectacular pink emission nebula located about 5,000 light-years from Earth, which measures some 140 light-years by 60 light-years across. The pink colour is caused by hydrogen. The central area of the Lagoon Nebula is also known as the Hourglass Nebula. That's because of its distinctive shape, which is caused by matter being propelled by a massive star-forming region known as Herschel 36. Herschel 36 is one of the few star-forming nebulae that's possible to see with the unaided eye. The Lagoon Nebula was instrumental in the discovery of Bok globules, more than 17,000 of which have so far been discovered in the nebula. Astronomers believe Bok globules contain embryonic protostars, destined to eventually become new stellar generations. One of the most recognizable nebula in the area is Messier 17, better known as the Horsehead Nebula. It's located some 4,890 light-years from Earth and is a dense region of ionized atomic hydrogen. It spans some 15 light-years in diameter and has some 800 times the mass of the Sun. It's considered one of the brightest and most massive star-forming regions in our galaxy, with a geometry that's very similar to the Orion Nebula, except that we're seeing it edge-on rather than face-on. The open star cluster NGC 6618 lies embedded in the nebulosity. It causes gas in the nebula to shine due to the intense radiation from these hot young stars. In fact, the nebula is thought to contain up to 800 stars, including over 100 of the largest, most massive spectral type O and B blue stars. More than 1,000 additional stars are also forming in the surrounding molecular gas and dust clouds, so this is a very busy place. In fact, it's one of the youngest clusters known in the galaxy, with an age of just over 1 million years. The cloud of interstellar material forming the nebula is roughly 40 light-years in diameter, and is thought to contain some 30,000 solar masses. Another nebula in this region is the Trifid Nebula Messier 20. It's another large star-forming emission nebula, containing many young hot stars. Located between 2,000 and 9,000 light-years from Earth, the Trifid Nebula has a diameter of approximately 50 light-years. I think the Trifid Nebula is especially spectacular to see. That's because it contains a bluish reflection nebula on the outside, while the inner region is glowing pink thanks to ionized hydrogen. And there are 2 dark bands dividing the Trifid Nebula into 3 regions or lobes. Hydrogen in the nebula is being ionized by a central triple star system, which formed in the intersection of the 2 dark bands, creating its characteristic pink color. Another star-forming region, NGC 6559, located some 5,000 light-years from Earth, also contains both red emission and blue reflection regions. This grouping of the Lagoon Nebula, the Trifid Nebula, and NGC 6559 is collectively known as the Sagittarius Triplet, certainly worth keeping an eye out for. Another spectacular sight in this region is the Red Spider Nebula NGC 6537. It's a planetary nebula some 8,000 light-years from Earth. It has a prominent two-lobed shape, possibly due to a binary companion or magnetic fields, and has an S-shaped symmetry, with the lobes opposite each other appearing to be really similar. Now, this is believed to be due to the presence of a companion star to the central white dwarf. It's the central white dwarf which produced the planetary nebula. The star at the centre of the Red Spider Nebula is surrounded by a dust shell, making its exact properties a little bit hard to determine. Its surface temperature is probably about 250,000 degrees, although temperatures of up to 500,000 degrees can't be ruled out, which would make it among the hottest white dwarf stars known. July also marks an important date in our solar system's astronomy, because it was during July 3 years ago that our solar system's barycenter moved outside the Sun, where it'll remain until 2027. Barycenter is the gravitational centre of mass for a celestial system. For example, in the Earth-Moon system, the Moon and Earth actually orbit each other around a common centre of gravity, the barycenter. And because the Earth is so much more massive than the Moon, the barycenter is always inside the Earth's radius. Were it outside the Earth's radius, the Earth and Moon would actually be classified as a binary system, like Pluto and Charon. The solar system's centre of gravity, or barycenter, is usually located inside the Sun's radius. After all, the Sun contains over 99% of the solar system's mass. But they're actually all orbiting around the solar system's barycenter, which means the Sun also has a very slight spiralling 12-year orbit around the barycenter. And every now and then, when the planet's orbital positions are just right, especially when Jupiter and Saturn are nearest to each other, their combined gravitational interaction moves the solar system's barycenter ever so slightly outside the Sun's radius. And because Jupiter and Saturn each have this alignment every 11 years, some scientists have speculated as to whether this could be triggering the Sun's 11-year annual solar cycle. And before you ask, the term barycenter isn't named after some dude in a beige safari suit called Barry, but rather the ancient Greek word for centre of mass. We also have 2 meteor showers this month, both of which peak in late July. Firstly, there's the southern Delta Aquarids, which we mentioned last month. It's still visible and will remain so until mid-August, with peak activity on July the 28th and 29th. Meanwhile, the nearby slow and bright Alpha Capricornids meteor shower will take place from around July the 15th and continue until around August the 10th. This meteor shower has infrequent but relatively bright meteors with some fireballs. It's generated as the Earth passes through the debris trail left behind by the comet 169P Neat, which was originally misidentified as the asteroid 2002 EX12. However, it was shown to be weakly active during perihelion and was thus reclassified as a comet. The meteor shower was created about 3,500 to 5,000 years ago, when about half of the parent body disintegrated and fell into dust. The dust cloud evolved into Earth's orbit, causing a shower with peak rates of about 5 meteors an hour, with some outbursts of bright flaring meteors, radiating out from the constellation Capricorn towards the south. The bulk of the comet's debris won't be in Earth's path until the 24th century. By that time, the Alpha Capricornids will become the major annual meteor shower, stronger than any current event. Okay, let's take a look at the rest of the night sky now, and for that we're joined by the editor of Australian Sky and Telescope magazine, Jonathan Nally.
We'll start, as we always do, looking down to the south, because that's where we like to look when we get out there here in Australia. So in the south, around mid-evening during July, you're going to see the Southern Cross up nice and high this time of year, standing almost exactly upright.
It sounds like you use the Southern Cross, because when we do this every month, you always refer to the Southern Cross. Am I right in thinking that you're using that as sort of the reference point to start the night out? Because I know that's what I do when I go sky watching.
Yeah, sort of. I mean, it's a constellation that everyone wants to see. When let's say you're not home, you're away at a conference or traveling or holidays, whatever, and you walk outside your hotel or something in the middle of the night or in the evening, and you try and get your bearings. So for people in the northern hemisphere, you've got the North Star, the Polaris, right, which makes it really easy. But for us in the southern hemisphere, we don't have a bright star right at the celestial pole. So where's the Southern Cross? There's the Southern Cross. So that's south. Okay, so that's east, that's west, that's north. You get your bearings that way. Yeah. And look, the area around the Southern Cross anyway is really quite lovely. You know, when it's up nice and high, this time of the year the cross is up nice and high in the sky. It's up virtually its maximum height above the horizon in the middle of the year. Whereas you come back 6 months from now and the cross is down near the horizon, and if you've got buildings and trees and things in the way, you can't see it. So it's a really good signpost to use for finding your way around the sky, and it's in an interesting part of the sky. Just to its left, we always mention this as well, is the 2 pointer stars, Alpha and Beta Centauri. So if you draw a line between those two stars and you keep that line going out, then it points pretty much towards the Southern Cross. That's why they're called the pointers. Now, the Milky Way, which is just our galaxy seen from the inside, that's stretching across the sky from the northeast to the southwest in sort of mid-evening in July. If you have a pair of binoculars and some reasonably dark skies, just take a look along the length of the Milky Way. It's just amazing. You see clusters of stars, maybe even a few nebulae, depending on how big your binoculars are. The area around the Southern Cross, in fact, and just to the right of the Southern Cross are particularly good. Lots of beautiful little clusters and stars and things. These are ones you don't pick up with the naked eye, and you don't know that they're there. But once you get your binoculars or a small telescope or something on, you think, wow, there's so much in the Milky Way. All these amazing little groups of stars and things and patterns. It's just incredible. And it starts to give you that feeling of, well, there's a big universe out there and we're part of it, but gee, we seem so small. And how many other, intelligent life forms are out there looking up into their night skies and perhaps looking in our direction thinking, I wonder if there's anyone living around that star, that little yellow star there. It could be. Now, one thing you will notice, though, if you're in a southern country like Australia or New Zealand or Africa or South America, is that the northern half of our sky this time of year seems pretty bare. There are a couple of bright stars. There's one called Spica, which is the brightest star in the constellation Virgo. There's another one called Arcturus, which is the brightest star in the constellation Bootes, right? And Arcturus, that brightest star in that constellation, is actually the fourth brightest star in the sky. Spica, on the other hand, the one in Virgo, is the 16th brightest star in the night sky. Now, they're up in the northern half of the sky seen from Australia. And as I said, it seems pretty bare, but that's a bit deceptive because for those who have backyard telescopes, it's anything but empty. For the constellations Virgo and another one nearby called Coma Berenices are home to thousands and thousands and thousands of galaxies. Again, you can't see these with the naked eye. You need a telescope to see them, and you need to sweep around till you find them, and then they start popping out all over the place. The bigger your telescope, more of them you're going to see. So, amateur astronomers actually love this seemingly bare part of the sky, and it's a good time of year to see it. For us down here in the southern hemisphere, it's winter. For our friends in the northern hemisphere, well, they've got the nice summer nights, of course. They can get out there and have a look when it's a bit warmer. Now, to the planets. What's happening with the planets? Well, Mercury and Mars, you'll find them both low down in the western sky after sunset. Mars, you'll be able to tell the difference between the two. Mars has a slightly reddish sort of colour. Mercury's a really bright white. It's very small, very tiny, like a little pinprick of light, and it's really bright white. And it's going to be in the sort of twilight glow after the sun has gone down. So you have to be quick to catch it before each of those set, not too long after the sun has gone down, in fact. On the other side of the sky, over in the east, you'll see a big, bright, white light. This is the planet Jupiter. It's really amazing at the moment, and even to the naked eye. With a pair of binoculars, get a pair of binoculars onto it, and you can see some little pinpricks of light either side of Jupiter, and that's big moons, the 4 Galilean moons, the ones that Mr. Galileo himself spotted. And if you have a telescope, or a friend's got a telescope, or your next-door neighbour or whatever, you can actually see cloud bands on Jupiter itself. And when you're having a look, even if it's just with the naked eye, just stop and think. There's a little spacecraft called Juno buzzing around Jupiter at the moment. It's been there for a while, and it's hundreds of millions of kilometres away, just doing its own thing, orbiting around that planet. I think that's amazing. Now, also in the eastern sky, but a bit lower down, is another bright white light. It's slightly yellowish. This is the planet Saturn. Again, good time to see this planet because it actually reaches opposition this month. And opposition simply means that seen from the Earth, the sun is in one direction and the planet is 180 degrees in the other direction. And the upshot of that is that when the sun goes down in the west, the planet is rising up and popping up over the horizon in the east. And that's really good because it means that you've got all the hours of nighttime to study the planet. So if you want to take long photographs, or perhaps when the sun goes down, it's cloudy over there in the east and you've got to wait till the clouds clear, well, you've got all those hours of night time to do that. So opposition is the best time really to see planets. It also coincides with when the planet is closest to the Earth. They don't necessarily happen to be on the same day, opposition and closest approach, but they're very close together. So Saturn's reaching opposition this month, so that's a really good one to see. If you can get a telescope onto Saturn, have a look, you'll be able to see the rings beautifully tilted towards us, because sometimes just the way our orbits line up, sometimes we see the rings edge on or very close to edge on and you don't really see them then, of course. So Saturn seems to have lost its rings, but at the moment, really good. And once we get past this opposition, a month or so past the opposition of Saturn, you should be able to also see the shadow of Saturn falling across the far side of the rings.
Oh,
so
wow.
That's pretty spectacular to look at too, particularly when you think of how big these planets are. Now, a couple of other things for July. We've got a couple of eclipses coming up this month, one of the sun and one of the moon. moon.
Hola.
Hola, say hello to the eclipse. But we will get to see a partial eclipse of the moon. That's coming up a fortnight after that on the night of July 16-17, or the morning, I should say, of July 16-17. It's not going to be the best eclipse ever seen. Not all of the moon is going to be covered up, and it's going to be beginning in the morning hours just as the sky is beginning to brighten with the dawn. So we're not going to see it for very long. But anyway, it's worth having a go. So that's the July 16-17. The next reasonably good eclipse for us here in Australia is going to come out in December. In fact, it's on December 26th. We're going to get a partial eclipse of the sun, but you have to be in the sort of far north of Australia, the northern half of Australia, to see it. The total solar eclipse will be visible from well north of Australia, sort of Western Pacific and through to Southeast Asia, that kind of thing. But at least some of us will see a partial solar eclipse. And that, Stuart, is the sky for July this year.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. You're listening to Spacetime. I'm Stuart Gary, and that's the show for now. You can subscribe and download Spacetime as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. Spacetime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more Spacetime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.